Welcome back to day 2 of HashiTalks build. We're live on YouTube, we're live on LinkedIn, and Kevin, I see your question. When are we starting? We're starting right now. In fact, we started about 13 seconds ago. So welcome. If you've joined us yesterday, you've made a great choice in coming back. You've already had plenty of good brain food. If you missed out on yesterday's sessions, you missed out big. Good thing is we'll have them on YouTube, but you'll definitely want to check in on how to get your Waypoint apps deployed in 60 seconds or less, how to manage Kubernetes with Terraform and the Flux provider. You can learn about Nomad at the edge, how to reduce your blast radius with Terraform, and enjoy a truly beautiful culture talk from Scott McAllister from PagerDuty. For today's program, we've got some pretty nice things for you scheduled. But before we get there, something a little more serious. This is a professional event. And so when you talk to each other, no matter if that's on LinkedIn or on Twitter or on YouTube, be kind, be considerate, and be respectful. If you see something that you don't like, let us know. We have our moderator standing by. We want this to be an inclusive event for all, and you're part of making that happen. If you need the full version of these community guidelines, head on over to hashicorp.com/community-guidelines. And with that, I think it's time to introduce our first speaker. Serge is going to be talking about reaching 3 million downloads and 90+% unit test coverage for a Terraform provider and what lessons they learned.
Hey, everyone. And I'm very delighted to tell a story about growing a Terraform provider and lessons learned for it, and how we got to 4 million downloads and more than 90% unit test coverage and other fun things. I'm Serge Martin, and I'm the lead maintainer of Databricks Terraform provider. And I worked on many different stages of data lifecycle over the course of past 15 years. And I worked in cyber threat security and built a couple of data science platforms from scratch. And my main job at Databricks is to grow strategic customers. So briefly about Databricks. Well, we are the Lakehouse platform. We define Lakehouse category. You're able to store all of your data, structured and unstructured, all in a single place. We bring the reliability and extremely high query performance to that data without leaving the data lake with an open technology called Delta Lake, so that you can use it for your all data warehousing workloads. Next, the Unity Catalog provides the governance abilities so that you can have fine-grained governance and security for your data in AI. And you can do data warehousing, data engineering, and data science and machine learning in a simple, unified, built on open source technologies with open standards across all of the major clouds like Microsoft Azure, AWS, and Google Cloud. So briefly about Databricks Terraform provider. It's a verified Terraform provider by as HashiCorp partner, and it's actually top 5% among all of the providers by a number of downloads, entities, contributors, and commits. Like we have more than 80 entities, and it includes resources and data resources, and it's growing because Databricks always adds new functionality. And we have more than 4 million downloads with 130,000 downloads every week. And the amount of code is approximately 76,000 lines of code. And there's a lot of reflection. So if we didn't use reflection, probably it will be way bigger. And 90% of that code is actually covered with the unit test coverage that runs for 40 seconds. And well, the first major thing is to tell you how a tiny bit of reflection won't actually hurt and can save like 50–60% of boilerplate code. Like here is a minimal working Terraform provider. Like we have the package main, we import a couple of things, then we have a function that returns schema.provider. And every provider must have a schema to define and validate the configuration. And there is also the configure context func that configures the connectivity to the backends, which result is later returned into all of the resources as part of the meta. So essentially, once you are having your schemas and configuration for provider and resources, you perform callbacks, creates, reads, updates, deletes. And essentially, once you connect to the backend, you create a resource by setting the ID field to something that signifies Terraform. Well, yeah, okay, we have a resource for it. Well, all in all, that's the simplest Terraform provider that is completely useless because it doesn't do much. But we had to experiment a couple of things a couple of times when we're performing Terraform provider GitHub organization transfer. So you see pretty much of a lot of boilerplate code. So within Databricks Terraform provider, we had to set a goal as minimal boilerplate for everything. Like we need to work on making things work instead of writing some auxiliary code. So here is the code from one of our resources. It's called customer managed key. Essentially, we register customer managed key for storage in AWS Cloud. And here we have a couple of interesting bits. So on the line struct to schema, we take a struct type and create a full Terraform schema with providing the ability to customize the schema. Then what we simply do, instead of setting the resource data for hundreds of lines, we just have one line, common data to struct pointer, where we provide a resource data, schema, and the empty type instance. Essentially, it's a very simple way just to set all of the relevant values from resource data into a data type without having to write hundreds of lines of data resource manipulation. Then reading that data is also simple. We do common struct to data, and given the CMK type instance and schema, we just set all of the relevant data fields, and it works. So overall, this is just approximately 60 lines of code to make a relatively generic resource. Normally, it used to be something like, I don't know, 500 lines minimum. So that saves a lot of time. But it has some drawbacks. So, for example, life is very easy for compatible schema changes because the only thing we have to do is add a line to a type that is already annotated with JSON type tags. And we've added additional type tag called TF, where we set things like computed, force new, and other things. Well, it's nice. But when we have to create things like state upgraders, we have to actually write it back as the normal schema in the code. So if you will think that reflection is panacea, it's not. It's just a way to move faster. But once you are doing some backwards incompatible changes, then yeah, it makes actually things a bit difficult. Well, all in all, benefits are tremendous because look at the job settings type. Like we have multiple different fields with multiple different configuration blocks, and we have the simplified validation type. So essentially, when one field is there, then other fields must not be there, etc., etc., etc. So for very complicated resources, this actually saves a lot of time, a lot of cycles for us to maintain the provider. And whenever reflection cannot cope with the schema structure we wanted to cope, we just provide a second argument to struct to schema function that just modifies the schema into the shape we want by adding more fields, by changing validation for those fields, and things like that. So as you see, we have the common overlay on top of Terraform SDK. What else do we have there? First of all, we are catching all of the panics in the recoverable callback. So that's whenever there's a panic in create, read, update, or delete, we actually present it as normal error. More on that on the later slides. Then we generically handle the cleanup of resources from Terraform state when they were removed on the backend, because as you know, from Terraform SDK, whenever the resource is removed on the backend, you have to set ID to the empty string in order to remove this resource in the Terraform state. And the other things we do here is just nicer error handling, like, okay, cannot create job, cannot update cluster policy, cannot delete workspace configuration, and so on, and so on, and so on. Like, we just add a prefix to all of the errors so that users are more confident by looking documentation or contacting our support when things don't work as user expect. The other thing we do in the common resource is reconciliation of state drift. So as you know, Terraform SDK recommends to call read callback every time you do create or update. Well, we hide it in the two-resource, common resource, and normal resource developers of this provider don't have to be calling read callback, making code way simpler to work with, way more testable, and allowing us to focus on writing the code that's needed and not actually making the reconciliation work. So that saves a lot of time also for importing the resources, because as you know, like by default, the importer for resources does not work. You have to explicitly define it, and we define importer for 98% of our resources, and it just works out of the box. For some things, we cannot really import into Terraform state, so we disable importer. That's essentially how we work with common resources. Like, another interesting use of modern Golang ecosystem is context with value. We use it to actually augment our user agent string for the provider that calls our APIs and provide in the resource name that is actually used. Why it's so important? Can't we just infer it from the API call? Well, not quite, because lots of resources at Databricks call more than one kind of API, and like those could be creating a mount. Creating a mount creates a command, creates a cluster, and then waits for cluster is up and running. So essentially, call like 5 different APIs, and we didn't know before, like, okay, what kinds of mounts were there, and how many actual customers were using mounts. So we invested a lot into actually telemetry and understanding how this provider is used in order to focus on the user experience and provide the best possible convenience for users. And obviously, we were focusing on the things that we use the most. Otherwise, it would not have making much sense. So essentially, context with value is set on the provider configuration startup level, and it sets the resource name to all of resources and data sources that are propagated down as a name to the user agent string, which also holds the Terraform provider, the Terraform version itself, because we need to know, like, our customers using Terraform 1.1, 1.2, 1.0, 0.13, and so on, and so on, and so on. Like, still, some customers are using 0.12 and 0.11. So they are there, and they'll be there. So this helps a lot. Then, other interesting thing I'm very proud is reverse engineering the deployments for customers who don't have infrastructure as a code yet. Like, essentially, it's a very complicated tooling that just looks at your existing Databricks Git repositories or clusters or other things and generates the HCL code for those, so that when customer is preparing for disaster recovery exercise, they can go invoke this Terraform exporter functionality and have HCL code TF files generated for all of resources that they've manually created for Databricks before, and have it all managed through version control through Terraform. Isn't it awesome? Well, it's actually awesome. And adding support for new type of resource for code generation is not that difficult. Here you see Databricks repo, and you have a couple of fields to define there, like defining service, defining the name of the resource callback, and then very interesting callback called listing. Essentially, listing is just the breadth first search that iterates through all of the repos and emits the entities that are there, sometimes matching the search criteria. And then there is another callback, post importing, which is essentially after we call the read context callback of Terraform resource, we also add things like permissions for this Git repository. Essentially, there is a command called Terraform add that tries to be baked into the Terraform core, but there is no listing. So once HashiCorp would implement something generic into their toolkits, yeah, I would be happy to pour this framework to something more generic, because there are plenty of tools similar like that, like AskTFI, Terraforming, Terraformer, or Terracognita. Why I decided to create yet another tooling for this? Well, first of all, there was nothing like that to support Databricks. Then it was easier to ship it in the same binary, just as another command. And I wanted to focus on the readable code. Like, here is the example for referential integrity resolution. Like, we generate the code for instance profile for a group, but then we have a resource that binds instance profile with a group. And by default, in a generated way, we just have plain text IDs. But the exporter functionality defines a relationship between different resources in the depends block, that it is able to replace the plain text identifiers with resource references, essentially making it very nice, simple, readable, navigatable code with Visual Studio Code for Terraform extension. Essentially, that's great. And whenever you are using Databricks, you should use, and not yet using Terraform, but want to, you should use Terraform exporter to generate the code. Then another interesting thing that we have in Terraform Provider is the HTTP Fixture framework. It's a strange testing technique that actually saves plethora of time. So how it works? For example, here we have a test something existing. So we define QA, HTTP Fixture, and we want to work with pure TDD. So that's the single test we write with some HCL configuration in, and we test the create phase of a catalog resource. That's it. Essentially, we run this test, and obviously it fails. Well, okay, what's so new about it? The good thing about it is that the failure almost fixes itself. It gives you the error as follows: missing stub, please add. And then it provides you with almost working code generated by heuristics so that you can take it and copy paste it into a test, change the response types and request types, then it works. So here is like the real example of the test. We have test catalog create also deletes default schema. We have a set of 3 fixtures. The first fixture, which is a call of HTTP post method to API 2.0 Unity catalog catalogs path with catalog info entity with name A, comment B, with properties C equals to D. Then we execute delete on another HTTP path, and then we execute get. So essentially, these are all things that these are all HTTP requests that are performed in the scope of create callback of Terraform resource, and we capture them in a single test that is debuggable and that is readable. Because we use these tests also as documentation. Because it takes a couple of seconds just to find the test, find the corner case, and just see what APIs it calls. And maybe engineer doesn't know Terraform structure at all, but them seeing this test actually explains a lot. And oh yeah, I know where's the bug, and they are able to copy paste this test, reproduce the failure conditions, and debug it, and work their way out to the resolution way quicker than with any other technique. Essentially, with debug test button in the Visual Studio Code, we're able to save tremendous amounts of time and have confidence in fixing issues or implementing functionality. So I totally recommend using the similar technique. Unit tests actually have very good correlation with the adoption. So here we have two charts. On the top, we have the trend of unit test coverage. And on the bottom, we have the relative adoption trend. And as you see, it takes approximately 2-3 months, or it took approximately 2-3 months for adoption to pick up after the tests were added, after the test coverage was actually increased greatly. And yeah, test coverage is more than 90% now. It's very reasonable. It's very high, considering the fact that most of Terraform providers rely mostly on acceptance tests. But I mean, come on, acceptance tests take, I don't know, hours to run. This takes 40 seconds to run and allows us to iterate fast, launch fast, and don't stop until we're done. So whenever you want to make something that's used a lot and installed, yeah, make sure it has a lot of unit test coverage, like more than 90%, because it really reflects well on the adoption of something installable like Terraform provider. But there are more things than just tests. Like Dependabot is awesome. Like we've been using it since early 2021, and yeah, it has made like more than 100 commits. It's like, what is Dependabot? Dependabot is something that looks at your dependency file, like Go mod, and finds newer versions of those dependencies and issues pull requests to your repository, sometimes also telling you, oh, okay, here are 2 files changed, Go mod and Go sum, and here's the changelog for this version. Yeah, please read it, please approve it. And by the way, we've run all of the unit tests for it, so yeah, it's completely safe to merge this pull request with updated dependencies. Yeah, like it's awesome because Dependabot does the course of maintaining the dependencies and making sure they are up to date, that security patches are fixed, that new functionality is added, and that's development's not stale. It's great until it's not, because like once we received an issue, hey, 0.38 plugin crashed, and we actually found out that there was an issue in the Terraform SDK for the happy path that was not covered by unit tests. So essentially, Terraform SDK version 2.8.0 added a functionality for data resource that was checking for something that was not there, essentially going to the nil pointer. So it was all-time favorite null pointer exception equivalent in Go. And yeah, it was panicking. It was crashing the providers. And after this, I really decided to add the recoverable callback to catch all of the panics and check it. So yeah, it would have caught this. Also, the other thing that could help to caught this would have been the acceptance testing for everything. But Acceptance testing of Databricks Terraform provider is a bit more complicated than others. Right? Well, we support all of the major clouds like Azure, AWS, and GCP. On Azure, Azure M provider creates Databricks workspaces, but for AWS and GCP, yeah, this provider creates workspaces. And there is another code path and authentication flow for creation of workspaces there. Then every cloud has its own peculiar ways of authenticating, like Azure Managed Server Identity Authentication or client secrets for service principals, or Azure CLI authentication to reuse the access token locally created by IEZ login tool. The same for Google. And for AWS, we also integrate with a couple of other techniques. And we also have Databricks CLI, so we want to reuse the authentication from there. And yeah, you see, that's the amount of our integration testing for acceptance of the provider is quite high. And we are working on running it more frequently, optimizing the runtimes and architecture. So this is how it's currently done. But eventually it will be something either simpler or more complex. Anyway, we are working on making sure that all of the acceptance tests are running more frequently, because it takes hours to run this, and it takes just 40 seconds to run 1,200 unit tests to give us 91% confidence in the validity of the code change. Then the other thing we've started doing recently is to add so-called architecture fitness function, where we just check that, okay, every resource must have more than 80% of fields documented, more than 60% of fields unit tested, more than 80% of fields acceptance tested, and all files have to follow same conventions, etc., etc., etc. Because we have very limited amount of time for supporting this. We do many things, and we want to enable all of the contributors that help maintaining this provider to follow the standards. Sometimes they don't know the standards, so we are working on ways to make sure that's contributing to provider is easy, and that all of the things are followed. And we try to automate as much as possible, and we try to have internal reporting as good as possible, and we try to focus and use data-driven decision-making process to actually improve this provider and build roadmap. So that's how we maintain a Terraform provider for Databricks. And I'm very excited to hear any feedback. So go to GitHub and create an issue or discussion, and happy that you start using it. And or I'm very happy that you learned some of new techniques from this talk. Thank you. Soris Merting from Databricks Amsterdam. We are hiring. Bye.
Bringing the energy right out of the gate. I love it. Normally, unit testing is dry and boring. This was definitely not it. Thank you so much, Serge. Yeah, I mean, how are we going to follow this up? I guess with our next speaker on creating Waypoint plugins. Joseph, you're up.
Hey everyone, welcome to my HashiTalk. And today I'm going to be talking to you all about Waypoint plugins and maybe how you could build one from scratch with just a little bit of help. But before that, I just want to introduce myself real quick. My name is Joe Rajewski. I joined HashiCorp a few months back, and I'm a software engineer on the Waypoint ecosystem team. But prior to joining the team, I was pretty active on the Waypoint GitHub repo. You may have seen me around there if you've been poking around. My username is Paladin Devops. But who is Paladin Devops? Well, even outside of HashiCorp, I was a big HashiCorp nerd. I got certified in Terraform, Console, and Vault. I've run Nomad clusters, Console, clusters, Vault, Waypoint, Boundary, you name it. I've tinkered with it in some fashion. But really outside of work, though, I love my new kitty, Suki. I've had her for about a year now, and she takes up quite a bit of real estate in my apartment with her plentiful cat toys and furniture. But yeah, when I really get out of my apartment, I love to go snowboarding. In Baltimore, Maryland, there aren't really many mountains around, so I do have to travel to make that happen. But this year I got an Epic Pass, so hopefully I can get out and see more of the country. But yeah, outside of that extreme activity, I love heavy metal and classic rock music, but pictured on the slide here is a pre-pandemic version of myself with the singer of one of my favorite bands called Fit for an Autopsy. But that's enough about me. Let's talk more about Waypoint plugins. So what are they? Well, our documentation says they are this, but I think of them as apps that are actually separate from Waypoint, but that Waypoint uses to perform the various operations that it can do, which include like builds, deploys, and releases currently. But what's a component? Because that's a part of the definition that we talk about in our documentation. Well, a plugin, or excuse me, a component is actually kind of like a type of a plugin, but a plugin can implement interfaces for multiple components. So a builder plugin, or rather a plugin that implements a builder interface, could also implement a registry interface or a platform interface and act as multiple components, but be the same plugin. So here's just a couple examples of those interfaces. Build, deploy, and release are the highlights of the Waypoint lifecycle, but yeah, these are what those interfaces look like. And these code snippets are pulled from the Waypoint plugin SDK. And basically, in your Waypoint plugin, if you implement these interfaces and your plugin uses them, then your plugin now can act as a builder if it implements the build func function and returns an interface, and so on here with platform. If it implements deploy func, it becomes a platform plugin, and release manager requires a release func. But yeah, let's get into a demo and I'll show you all how to make a plugin. All right, so now we made it through the super fun slides. I'm going to do what I promised and show you all how to create a Waypoint plugin. But we're actually not going to be doing this completely from scratch, and we are going to use a good bit of help. This Waypoint plugin examples repository on the Waypoint, excuse me, the HashiCorp org on GitHub has a script in it that can help us get started with creating a plugin way faster than trying to figure it out all by yourself. So something I want to add here, though, before we get into it, is that this is actually how I got into plugin development when I was still a part of the community before I worked at HashiCorp. I had really little idea where to start, but the documentation led me here, and this is definitely a great way to get started. So let's first clone down this repository, and I'm going to open up my Waypoint colored terminal, and we're going to hit clone, and let's move in there and see what is going on. And at first glance, it looks like some basic Go stuff, you know, Go mod, Go sum. There's also a plugins path, which contains some examples of plugins. We're not going to look at that right now. We're going to focus more on generating code for a new one, but if you need to check out some example code for a plugin, you can check there, or currently at the Waypoint repository. But in the template path, we have a bunch more stuff, including a make file and a Docker file used for building the plugin, but also some additional folders, including builder, platform, registry, and release. You probably remember that from just a few moments ago when we talked about the various different kinds of plugin interfaces that you can implement with a plugin. But yeah, for this demo, we're only going to be implementing the builder interface because what I'm going to be doing is creating a builder plugin for Packer to build Packer images. For those of you who don't know what Packer is, it's another HashiCorp product that specializes in building machine images for any platform you can think of, whether it be VMware, Docker, AWS, GCP, Azure, many others. If you can think of it, there's probably a plugin out there for it in Packer. But anyway, that's the plugin we're going to be building. So let's clone this template into a new template that we can use for our new plugin. So let's see what clone.sh wants from us. And it looks like we need a name, a location, a name for our plugin, and a location on our file system to store the new plugin code, and the name of the Go package for our new plugin. So let's give it that and see what happens. We're going to call it Packer, and we are going to put this in my Go source path at github.com, and then my personal GitHub or Paladin DevOps, and we're going to call it waypoint-plugin-packer. And the Go package name is going to be named the same thing. So we just github.com/paladin-devops/waypoint-plugin-packer. Excellent. Okay, now let's change directories over into our new plugin. And it looks just like the template path did. All the same content is here, except it's now some values have been populated in these files specifically for a plugin named Packer. And that's enough in the terminal, though. I'm going to pop over to my IDE, and I like Golang, so that's what I'm going to show you all here. All right. We are going to start off in here by looking at main.go. And right off the bat, you can see a few import statements. There's 4 of them, in addition to the Waypoint plugin SDK. But these first 4 are packages that are in this repository. And they include the builder, platform, registry, and release packages. But I mentioned we're only going to be creating a builder plugin, so we're only going to need that particular package. So we'll clean this up in just a second. But just wanted to point out here that your plugin can implement more than one interface. Like I could have this Packer plugin do what I initially said, which is act as a Packer builder, run Packer build to create a machine image. But I might also want to publish that image metadata in HTTP Packer, which sounds like a pretty good use case for a registry plugin. And therefore, we could potentially also implement the registry interface to make this plugin act as a registry as well. But in this case, we're just going to be making a builder. So let's get rid of the interfaces we're not going to implement. And Golang cleaned up my imports for me, which is great. And yeah, let's take a look at our builder package. All right, start off here at the top. We have a few more imports here, a couple from the Go standard library, but something extra here is from the Waypoint plugin SDK, and it's a package called Terminal. And this package is used for outputting information to whoever's using your plugin on their CLI, so that way they can kind of see what's going on with their Waypoint operation. But we'll see that in action pretty soon here. Next, we have the build config struct, and this configuration actually defines what can be what knobs can be turned in your waypoint.hcl for your plugin. In this case, the template has a configuration for the directory, and this can be used during our plugin build operation or our Waypoint build operation if we need it. If we don't need it, we can probably get rid of this, but this is what the template provided us. We're going to be adding a couple more things here in a bit for Packer specifically, but we're going to leave it as is for the moment. But the way that this is consumed by Waypoint is through this config interface. This is what actually enables the configurations to be set in your waypoint.hcl. And we can see right here that this b.builder, or excuse me, this builder type, which is defined just above the function here, is returning the config field from the struct. And that's how Waypoint consumes it. But taking a closer look at this struct, the builder struct is actually what's implementing the builder interface to make this a builder plugin. The configurable interface is optional, but in general, plugins tend to have configurations. It's not absolutely necessary, but they can, and this one does. But builder becomes the builder plugin by implementing the function build func, because that's the interface for a builder plugin. And build func returns b.build. And b.build is featured just a little bit further down this file, which is just another function with the builder type as the receiver. And in this function is where you actually write the code that's going to perform the actions of your plugin. In this case, it's going to be a packer build. So the packer build command is actually going to be initiated from this build function. And yeah, we can just get started on making that happen. So let's do that. All right, so the first thing I'm going to need is something that can execute a command in Go. And fortunately, the Go standard library has something like that for us. And it's in a package, which is a package called exec, which allows us to run commands. And we're going to say the command I want to run is packer, but we can't run packer build right away. For people out there who use packer, you must know that you have to run packer init first to initialize your packer configuration and get any plugins that are needed and all that important stuff to make your build happen. So packer init, and packer init is followed by a path for wherever your packer configuration exists. So fortunately, we have a config option already defined in our build config called directory. So we can actually use this and say that we want to use b, which is our builder.config.directory. And that's great because now the user can configure where they want where their packer configuration is, even if it's not in the same directory as the waypoint.hcl file. So now that we have that, we can run, or rather we're going to set error equal to o.run, which actually runs the command and returns an error. And we're going to check if that error is nil before we move on. There is not equal to nil, then we are not going to return a binary, and I'll get into these this return type in just a few minutes here. But we're going to return nil and the error back to whatever is calling this function. So now at this point, the packer configuration will have been initialized because packer init has run with the directory that it needs. So with that done, the next thing we need to do is actually run packer build. So let's just copy this this code we just used. Let's zoom in here. All right, packer build. And we're going to keep the same directory because we want to build the configuration that we just initialized. So it's pretty nice that we can refer back to the same configuration. And these have already been instantiated, so we don't need a colon there anymore. And that's looking pretty good because packer init's there, packer build is there. Yeah, I think we're good. So let's give this a dry run. First thing we need to do though, before we can use the plugin, is build it. So let's run make build because we have a make file here. And this is just going to run go build with excuse me, in order to create the various variations of the binary based on your operating system. I'm running on Mac, so I'm going to use the binary that's been copied into Darwin AMD 64. So let's copy that. We need /bin Darwin and Waypoint plugin packer. There's our binary. But to install it though, we can copy this file to a directory that Waypoint reads by default when it tries to search for a plugin. Because in your waypoint.hcl, when you specify a plugin with your use stanza, Waypoint goes and looks to see where that plugin is. So let's, or rather on a Mac, that's going to be in my home path in the library preferences folder. And that'll be under Waypoint and then the plugins folder within that Waypoint folder. If you're on a Linux machine or a Windows machine, it's going to be a different path. On Linux, it's probably going to be your home path.config/waypoint/plugins, if I recall, but you might want to check the Waypoint documentation to verify that. So we're going to copy that file there, and that part is done. Next, we need to create a waypoint.hcl file, which can actually attempt to use this plugin. So at the top of our waypoint.hcl, we require that there's a project name currently. So we're going to call this HashiTalks builds and add waypoint on the end there. And we're going to say our app is of the same name. So HashiTalks-build-waypoint. And we are going to write our build stanza, and that build stanza is going to use the Packer plugin. And we have a config option called directory, and we just want that to be our current directory. That's where I'm going to add the Packer configuration file in just a moment here, after we get to the waypoint file. So that's the end of our use stanza, and that's the end of build. And we're not going to try and use this build artifact in any deployer yet. So I'm just going to use the exec plugin as an escape hatch really quick, just to run a command for us. And we're just going to say echo done. And close up that use stanza. Oh, messed up the curly braces there. All right. And that should do it. All right, so that's a pretty good looking waypoint.hcl file, pretty simple. It uses our new plugin called Packer. So let's save that guy. And we'll run waypoint fmt just to make sure it's formatted nice and pretty. And now we need a Packer configuration to, actually start doing something with Packer. So let's just call this waypoint, or now let's give it a different name, HashiTalks.pkr.hcl. This is the naming convention for Packer file configuration files. And I've already written this ahead of time, so we're just going to go ahead and copy that in here. And this is pretty simple. It's just going to be pulling down a tagged Ubuntu image and exporting it into a new tag on my local machine. So without getting too deep into this yet, let's save that file. And let's try and run waypoint build. Similar to Packer, you need to run waypoint init before you run waypoint build with a new project. So let's run waypoint init now. And now our project has been initialized. And waypoint build is going to kick off our build. And it tried to run the build with our new Packer plugin, but something went wrong. We didn't get a lot of information though, because we didn't output anything into the user that could help us diagnose what's going wrong. But we know there's something wrong because we got exit status 1 here. So we can take a look inside of the Go code and see what's going on. So we've got Packer build here, and this is just Packer build dot, which is our current directory. But in our Packer configuration, there will be HashiTalks.packer.hcl. I have a few variables here that are required. They don't have default values. And if it doesn't have a default value, then the Packer run is going to fail if something isn't provided for these variables. So let's head on back over to Goland, and we are going to take an opinionated stance on what needs to be added here. This is going to now require, for this plugin to operate, 2 variables, one called image and one called tag. So we don't have any configuration like that, though, from the user. There's currently no way to provide variables into the Packer build execution. So we need to add a couple of additional build configs. So we're going to call one of those things image, and we're going to give it an HCL tag and call that image there. And we're going to say that it's an attribute, which means that it is required, it is not optional, and that the user therefore must provide it. Okay, and let's add a second one called tag, HCL, tag, attribute, and great. We're also going to say that the directory is required by labeling with attr, because Packer build and Packer init both need a directory. So now back down here, we're going to add a couple of additional flags to be passed to the Packer build. run. So we're going to say -var equals image equals, and then concatenate the actual config, the image name from the config that the user provided. So we're going to say b.config.image, and we're going to pass one more variable here, -var equals tag equals, and we're going to say b.config.tag. Excellent. Okay. And again, for people out there who may not use Packer, you can provide variables as flags on the CLI with Packer, just like you see here. It would be key value pairs. Image is the key, and then the value is going to be the configuration that we provide here. But you can also provide things in a file with a flag called var file, and then you pass in the file name. But in this case, we're going to take an opinionated stance, require that the user provide image and tag as variables, and we're not going to accept any files as input variables. So now that that's done, we need to rebuild the plugin. So we're going to make build again. All right, we've got that created. Now I'm going to use a command that I ran earlier to copy the new binary into the Waypoint Plugins path. So we've got that done. I'm going to clean this up just a little bit, and we're going to try running Waypoint build again and see what happens. So now we didn't get return code 1. We got a little bit different of an error. And we can see here that we are missing a required argument called image. And when I was updating the build config, you probably heard me say a couple of times that labeling something with the HCL tags as ATTR attribute means that it's required. So Waypoint actually detected this just based on those tags. And I didn't update the waypoint.hcl file because you can see right here, the only configuration that we have still is directory. So let's add that additional stuff. And we're going to say our image name is just going to be Devops Paladin /Ubuntu. And our tag is going to be latest. All right, now I'm going to run Waypoint FMT again because I like things to be neat. And let's try one more time to make this Waypoint build happen. Please stand by. All right, it's done. That only took a few seconds, and our build has completely finished. So let's run Waypoint artifact list builds. And we can see here a few minutes ago, our build failed, but this time it didn't. So there we go. That's our first execution, successful execution of the Packer builder plugin. But we've got this empty binary struct that's being returned back to the caller. And nothing really useful is being passed in here, but what is important here is that we provide some kind of artifact information back to Waypoint so that in the next part of the Waypoint lifecycle, and what comes after builder is the registry stanza, we want to provide that information about how can we push this build artifact to some repository. So this is not, or what we just built was a Docker image using Packer. We did not build a binary file. So what we're going to do here is rename this and then give it a couple of attributes. And those attributes are just going to be the image name and tag that we provided as input, but we're also going to provide that back to Waypoint as the artifact. So in order to do that, we need to actually update the protocol buffer definition for this plugin. We can see here we have the message binary that's defined, but I'm actually going to rename this to image. And we're going to give it a couple of fields here, and we're going to say string, and we're going to say image name and string tag. Cool. And if we go back over to builder, everything's still fine because the protocol buffer code that's been generated for gRPC still resembles the old type binary, but we need this to now change to become image because I just updated the the definition here. So let's do that with a command in our make file called make protos. So we have a couple of errors here, and it looks like these are happening in our platform plugin, which we're not going to be using here. So let's go ahead and remove those from our make file. And yeah, it's attempting right now to build the plugin for each type: registry, platform, and release, and builder, but we're going to remove the ones that we don't need. So let's try that one more time. All right, it is done. So this output.pb.go just changed, and it now should have a type that we can use called image. If I search for that in here, yep, there, right at the top, image, and it's got a couple of fields, image name and tag. So we go back over to builder.go. My IDE is now unhappy with me because there is no longer a type called binary in this package. There is, though, a new type called image. If we can autocomplete, excellent. So we've got image here, and that is our new return type, and binary doesn't exist and it doesn't match the return type. So we need to change that to image. And we're going to fill all of our fields here. And we are not going to use state, /cache, or unknown. We're going to just provide the image name and tag. So b.config.image and b.config.tag. Excellent. Okay, now let's try building this plugin one more time. Make builds. All right, it has been built again, and we're going to copy that plugin to our plugins folder, and we're going to try running Waypoint build once more. Please stand by. All right, so now let's do Waypoint artifacts list builds, and we have a new build, and let's just look at our artifacts. And we can see 10 seconds ago, we pushed a new artifact. We can't, or there's nothing really to inspect here at the moment, but in theory, if we had a registry plugin, which consumed the protocol buffer definition for image, then that image could be used in the next part of the Waypoint lifecycle and could be pushed to some remote repository, or in the example I mentioned earlier, that could potentially be the Waypoint, the HashiCorp Cloud Platform managed service for Packer. And maybe we could do something with that later on with a deployer plugin or a releaser. Yeah, but that's pretty much it, guys. So that's how you create a plugin from scratch. And I hope this helps you all get started writing plugins. If you have any questions, you can reach out to me or anyone on the team on GitHub or discuss. And we're always happy to help. So thanks for watching this HashiTalk, and hope you enjoy the rest of the day.
If plugin creation is really that simple, kind of have to ask yourself, like, what's holding you back from building a plugin? And what kind of plugin are you thinking of building? If you have any ideas, let us know in the chat. Tweet it out, #HashiTalks. We're curious, and we'll probably invite you to the next one to show what you've built. Next up, we've got Louis talking about the Polyglot Devops, translating Docker Compose YAML and Kubernetes to Nomad. Super excited for this one.
In this talk, we're going to cover the Polyglot Devops and how to translate Docker Compose and Kubernetes files to Nomad. Hi, my name is Louis Aki, and I'm a software engineer at HashiCorp. So when working with DevOps, you're likely to encounter several different languages across several different tools. So let's look at some of them. The first one is Json. It's a data format that represents objects and is focused on machine-to-machine communication, but is still reasonable for humans to read. It's a fairly rigid language, so there's no comments there's like strict rules for commas, but it's a very common language. Another common language is YAML, so that's what's used for Docker Compose and Kubernetes. It has more human-friendly features like comments, and it allows you to have line breaks to group content. And it's also more flexible in terms of representing data types. So you can have, for example, strings with or without quotes, or you can have lists as a single line or multi-line format. And then another language is the HCL. So that's the HashiCorp configuration language. It's less common than the previous two, but you're probably seeing in things like Terraform. But it's actually also used in other HashiCorp tools. It's also a very human-friendly language to read, and it's centered on this idea of blocks. So before you write anything in Nomad, you kind of need to know HCL, since that's the basic language that is used. So let's look at some of the language features. As I mentioned, HCL is organized around this idea of blocks, and blocks are limited by curly braces. Each block has an identifier and 0 or more labels. And then inside the block, you have its body. And the body of the block can have attributes or other blocks. Attributes have this format of an identifier, $, and an expression. And the expression can represent other things and generate other results if you're calling functions, or just represent directly some data types. So for example, a data type here is a list, but it could also have a string, a number, or things like booleans. And one data type that is fairly common to get confused is the map data type, because it kind of looks like a block since it uses the same curly brace syntax. But notice here in the example that a map is going to have that identifier equal expression format. So the map will have that equal sign, whereas a block without a label would not have that equal sign. So now that we know a little bit about HCL, let's look a little bit about Nomad itself. So Nomad is an orchestrator, which means it's a tool that runs things across your infrastructure and make sure that they keep running. There are many things to cover in Nomad, but today we're going to focus specifically on the things that run in Nomad, and more specifically on how to translate things that run in Docker Compose and Kubernetes into things that run in Nomad. So what are those things? Well, they're jobs. That's the top level concept in Nomad. And a job is the logical unit that defines the general scheduling information for what you want to run. It's also what you use to stop and run. So when you run a job, you run everything. When you stop everything inside the job. And jobs are made of groups. So the group defines the scheduling unit, meaning that everything inside a group is going to run together in the same machine and the same sort of isolation unit. And when a group gets scheduled to a client, that's what's called an allocation. Inside the group, you also define the unit of scaling. So you have this count attribute in the group. And if you change this number, you're going to change the number of instances or the number of copies that you're going to run for the group. Inside the group, you have tasks, which is the unit of work that you want to run. And since Nomad is a flexible orchestrator, there are different types of tasks that you can define. The most common one is the Docker, but you can define others and then use the driver attribute to specify which type of task you're running. And then each driver is going to have its own configuration that you define as a block. And here you're going to define the image that the Docker container is going to run. So now that we know a little bit about the basic of HCL and Nomad, let's see that in practice. So for this presentation, we're going to translate the OpenTelemetry demo that is available on the repository here into from Docker Compose into a Nomad job. So let's first look at the Docker Compose, and you can see here that it defines several services. So the first thing we need to know is understand the general view of the application. So let's go over there. So we're going to have several services, but the main one is going to be a client that makes a request for a server, and both units will expose tracing data to the OpenTelemetry collector And then the OpenTelemetry collector is going to forward that information to a Zipkin deployment and a Jaeger deployment, and then we can access the web UI to see the data. So the first step to translating a file from one language to another is to understand what the file is doing. So now that we know that, let's see how to do that in practice. So I'm going to start a new file. It's going to be the translation of the Docker Compose version into Nomad. And as I mentioned, we're going to use HCL here on the right, and then we have the YAML version for Docker Compose on the left. Since this is a demo, I'm going to put everything inside the same job. In production, you'll probably break this into multiple services. So more likely that each service on the Docker Compose side would become a separate job in Nomad, so that you have more control over when to run and where to run those jobs. But since this is a demo, I'm going to just put everything inside the same job. So let's create the job here. I'm going to call it hotel demo. And as I mentioned, the job is the scheduling unit. So the only requirement attribute here is which data center we want this to run. So I'm going to use DC1. That's the Nomad default. Don't specify one when you start the agent. And then inside the job, we have the different groups. So I'm going to map each service on Docker Compose to a group in Nomad. And that's because on Docker Compose, you can have different number of instances for each service. So that kind of maps to the group in Nomad, as we see before. The first one is going to be the Jaeger all in one group. And I'm going to run a task inside the group. And since this is Docker Compose, this task is going to be a Docker task. And for the configuration, I'm going to specify which image I want to run. And I'm just going to copy the value correct on the file. So that's what we need to do to run a Docker container in Nomad. So up until here, we have up until here. Now, the next thing is that the Docker Compose defines some ports. Now, how do we do this in Nomad? Well, as you've seen before, the group is the unit of scheduling. So everything inside the group runs in the same machine, and it also shares resources. One of the resources that gets shared by the group is the network. So I'm going to create the network block here to describe what my group network should look like. And in this case, I'm going to set some ports. So the first port represents the Jaeger UI. And you can see here in the notation, when you have two ports here in Docker Compose, it means that it's going to map a specific port in the host to a specific port in the container. In Nomad, we do this with the static attribute inside the port. So we're going to create a static port number 16686 on the host, and we're going to map to the container on the same port. Since they're the same port, this second attribute is optional. Nomad is going to default to that. But just to make it more like a one-on-one comparison, I'm going to leave both there. Now the second port, so this is used by Jaeger to receive data in the Apache truth format. And as you can see here, there's no host port specified. So I'm just going to put the to attribute on the port. Now, what this means is that Nomad is going to get a random port that is available on the machine that runs this, and it's going to assign to this container at this port. So I don't have to manually manage this port. And that's usually the best approach, is to avoid static ports if you can, and only use those for specific services that you want to have like a stable address to reach. So for example, the UI, we want to access from the browser, for example, so it's good to have a specific port to use. But for things that are more dynamic, we leave that for Nomad to pick a port. So next up, after we declare our network group information, we need to map these ports into the container. Remember that a group can have multiple tasks. So we need to tell Nomad which of these ports the container should be using. Since we only have a single task here, all of the ports are going to go into the same container. So I'm just going to list them here. Okay, so like that's all we need for the Jaeger service. It's a little bit more verbose than Docker Compose, but we also get a little bit more. So like we have more control over how to declare a port. We have more human-friendly labels attached to the port, so I don't have to kind of guess and look at the documentation what these different ports means. So yeah, it gives a little more features. The next service is the Zipkin service. Again, going to be fairly similar to the Jaeger. So I'm going to create a new service for the Zipkin app. And again, there's a port. So let's configure the group network with a port for the UI. That again, it's going to be static because we want to access this port easily, but in general, you wouldn't use static ports like this. Then we declare our task. That is going to use the Docker driver and the configuration. We're going to specify the image we want to pull and which ports we want to map from the group to the task. So that's all we need for the Zipkin. Again, fairly simple, just like the Jaeger. Now things are going to get a little bit more interesting with the OpenTelemetry collector because it has a lot more going on. So let's jump right in. So that's going to be the OTel collector group. And now you see a lot more ports here. But again, it's just the same syntax. Now we have some nice comments to help us figure out what they are. And we can do nice labels for them. So the first is for pprof. As I mentioned, when you're using static ports and you want both ports to have the same value, you don't need to specify the two. So since there's a lot going on here, I'm going to use that and just define the static for this ones. But you could definitely set both. So we have the Prometheus, 9. Next up, we have the health check. Or 13123. Then we have this is the gRPC port, and you can see that it doesn't have a host port, so it's going to get a random port from the host, and it's going to get mapped to this port into the container. And then 3 pages. The last one is going to be 5, 6, 7, 9. Okay, so these are all the ports that our group will have. Now to define the task, then driver Docker, then the configuration. We're going to use the image. Now, if you see the image here, it's using an environment variable. So the way we map those into Nomad is you can also declare variables on your job. And here I'm using the variable. Now I need to declare the variable. I'm going to do at the top of the file here. There are a few syntaxes that you can use. I'm going to use this one that allows me to define several variables at once with their default. I'm going to grab the default from the .m file that normally, if you're using Docker Compose, that gets loaded automatically when you do a Docker Compose up. So that's how we declare that part. So now we have the image. And then we have the command attribute next. So in Nomad, that's going to map to the args configuration, and we're going to get a list. But before that, notice that we're also using a variable here. And instead of declaring a list directly, what I'm going to do is I'm going to use a HCL function called Concat that is going to concatenate 2 lists for me. And the first list is going to be this hard-coded value here. And then on the second list is going to be a variable, just like we have on the Docker Compose version. Then let's go to the top. Declare that the default value is an empty list to begin with. But now we're going to use the HCL function to concatenate these two lists so that users could customize at runtime more arguments to pass to the image. Next up, as we've seen before, we need to map all of those ports to the container here. So since there's only one task, all of those ports are going to go into the same task, which is the collector. Cool. And then finally, another thing, so there's another new thing that we haven't seen before are volumes. So on Docker Compose, volumes are used to map files and directories from the host inside the container. When using Nomad, this is not a good practice to do because Nomad, as I mentioned, runs things across the whole infrastructure. So you cannot rely on specific server data, specific state or specific files into the machine. Everything that you want to run needs to be shipped with the job. So that's exactly what we're going to do. First, let's create the volume mapping configuration. So this is going to look similar to the Docker Compose. The only difference is that instead of reading from a relative path in the machine, you're going to read from this specific special local path, which is the file system that Nomad creates for the task. So when Nomad run a task for you or it creates an allocation for a group, it also creates a file system specific for the group, and that's mounted into this local path. And the file is going to be called hotel collector config YAML. And we're going to map this file inside the container at this path here, etc hotel collector config YAML. Okay, now what's the content for this file? So as I mentioned, everything that you want your Nomad job to have, you need to ship with the job or download from the internet at runtime. We're going to ship the configuration file with the job, and we're going to do this with the template block. The template blocks allow you to specify arbitrary data that is going to be stored into the task file system. So we need to specify the data for the template, and I'm going to use this multi-line syntax here. And we need to specify where this file is going to be stored. I'm going to store the local directory for the task. That's the file name that I use here to map inside the container. Now we need the content for the file, so I'm going to grab it from the repository as well. So that's the hotel config file here. I'm going to grab the raw version here, and I'm going to paste it here. That's where my syntax highlight gets a little bit confused because there are multiple languages going on, but we'll manage. So this config file configures the OpenTelemetry collector that is collecting the data. It's also exposing some of that data to different formats. So one of the formats is Prometheus. And you can see here that it's referencing one of the ports that we created above. So now, instead of using the number here directly, what we can do in Nomad is we can read this environment variable with the Nomad port prefix. And what it's going to do is when the task runs, Nomad is going to replace this value with the value for the port. Now, we're using a specific value here, so it's always going to be that. But if we were to change this, for example, we wouldn't have to change our file anymore because Nomad would correctly set the value here for us. Another thing that the file is doing is also exposing or sending the data to the Zipkin and to Jaeger. Now you can see that it's using, since this is a Docker Compose file, it's using the Docker Compose internal DNS to find the other service. So when you're doing Docker Compose, you can reference services by their name directly, and then Docker Compose will make some magic to forward your request to the right place. We don't have the same capabilities in Nomad, so we're going to use service discovery to do that. Again, there are multiple ways to do this. I'm just going to do the simplest way for now, but in production, you would do something a little bit more robust. But let's look at first like the sort of the simplest way to just to get started. The first thing we need to do is we need to instruct Nomad to store the information somewhere. So we need to know which IP and port we need to reach when we make this call. The way we do this is when you go to the Zipkin group, we're going to create a service, and we're going to give a name for the service, and we're going to say which port the service should listen on. And I'm also going to specify the Nomad provider. So what this means is that Nomad is going to use the native service discovery that shipped with Nomad 1.3 instead of default console as the service discovery mechanism. So now that we know which IP and port this service is running, or this allocation is running, we're going to query that information from the template. So to do this, the template data can use console template functions. And so we're going to use a function called Nomad service to query the Zipkin service. And again, since this is a demo, I'm just going to get the first entry on the service. So for example, if you have multiple instances of the Zipkin running, this would return a full list of all the options that you have. Since this is a demo, just going to get the first one, but in a more production environment, you would have something like a load balancer or an ingress to distribute the traffic. So now that we have the first service instance for Zipkin, I'm just going to replace here with the address port for that first entry. So now when Nomad runs this task, it's going to render this file by querying the Nomad API to get the service called Zipkin. It's going to get a list of services, a list of IP and ports. It's going to get the first entry, and it's going to replace here on this file. And I need to do the same here for Jaeger. So let's go to the Jaeger group and create a service with the name Jaeger report. So this is going to use the gRPC port, and the provider is going to be Nomad. And I'm going to add another configuration called the tag, because since the Jaeger group has multiple ports, you can use tags as sort of a subdomain for the service to specify a specific port that you want to reach. So let's see that in practice. So now here in my template, I'm going to do similar process of querying the Nomad API, but now instead of querying the Jaeger service, I can do grpc.jaeger to only get that gRPC port. Now here is the address. Here is the port. So now whenever this file gets rendered, Nomad is going to go query the API, get the port, the IP and port for the Jaeger gRPC service, and replace it here. Again, this is a very simple way to do service discovery. In production, you would use something like Traffic or Fabio to do proper ingress load balancer. But here for this demo, that will be enough for us. Let's run this job, even though we don't have everything, we can at least get a first run and to type variables properly. Oops, I forgot the name for this task. And now we have our job running. So if you go to the Nomad UI, you can see the Nomad is starting all of our groups, all of our tasks, and now they're all green and running. So we successfully translated those services from Docker Compose to Nomad. If I do a Docker PS here, you can see all the containers and other ports. For the other services, so let's go back to the Docker Compose file. They all look fairly similar, so I'm not going to go over the details of each one. The only thing that I want to call is this environment. So this is something different from the other services we've seen so far. So I'm going to open the finalized all done version here, just to show how that environment looks like. And this is the client that generates traffic to the server. And it's configured by environment variables. So similar to how we've done the OpenTelemetry agent configuration with a configuration file, you can also use the template to render things as environment variables. So here we are doing the same sort of simple service discovery mechanism to get the first instance of a service and just rendering a file with the address import. But we're also setting this attribute of true so that Nomad loads these values and its environment variables. Cool. So now let's look at a Kubernetes version. Now that we kind of go over the details on Docker Compose, the Kubernetes version is fairly similar. I have it ready here. One thing that is different is that Kubernetes has a lot more functionalities than Docker Compose, and one of them is that you can have different kinds of workloads. So this OpenTelemetry agent, for example, runs as a daemon set. If you open the equivalent Nomad job, that will be a type system. So that runs in all of your clients, in your infrastructure, in your data center. So that maps to a daemon set. The other thing we kind of seen as well, how to do it on Docker Compose. So how do you specify a command? Well, you can specify in this case as an entry point. You have ports. One thing we didn't see in the Docker Compose was resources. In Nomad, you can do the same for CPU and memory. They just have different units, but they're fairly easy to match. And then in Kubernetes, you have this config map entity that you specify, the whole content. So similar to seeing this on the previous examples, we use a template to sort of emulate a config map in Kubernetes. And then the other entity that we have here is a deployment, and that in Nomad maps to a type service, which is actually the default. And then a deployment in Kubernetes, you have the number of replicas. In Nomad, you have a group count, so how many replicas you want to run. To get more information on how to map Kubernetes concepts to Nomad, we have this blog post that goes over into more details, and it also has this cheat sheet that you can quickly map, see how things map from Kubernetes to Nomad. And all the material that are presented today is available on this repository here, the Nomad Open Telemetry Getting Started. Here in the examples folder, you're going to see all the files that I generated and also instructions on how to set up your environment and then local Nomad agent dev. And that's what I have for you. I hope you enjoyed, and thank you very much.
That was beautiful. This is the languages of DevOps, and approaching it this way is just a beautiful way. I think Someone with comments in chat said it the exact right way. This is awesome. Thank you so much, Luis. I think we'll actually have that talk back for HashiTalks Brazil. So if that's your kind of HashiTalks, definitely come back at that point. Up next, we've got Rafael with how to test your Terraform code.
Hello, everyone. Welcome to this session on how to test your Terraform code. The objective for this session is to demonstrate the usage of the Terraform testing module. Before we begin, let me introduce myself. My name is Rafael Natali. I am a senior DevOps engineer at Marionette. I have been working on the DevOps ecosystem for over 4 years now. And since 2020, I am a Terraform Associate Certified Professional. Today's topics, we're going to talk about why we need to test, why the Terraform plan is not enough for testing, introduce the Terraform test command, you see this command in action, and at the end, talk about some of its current limitations. Why do we need to test our infrastructure? Testing infrastructure is as important as testing applications that run in the infrastructures. Considering an approach based on test-driven design, the idea is to convert infrastructure requirements into test case to make sure the code is working as expected and to catch errors as soon as possible. You can say that, okay, I am running the Terraform plan, so I know what's going to happen in my infrastructure. Terraform plan is a great starting point, definitely. However, it does not cover everything, all the cases. For example, if you don't have permission to create a resource, you will only find it after the Terraform apply, not during the plan. The plan is not going to fail. So, as I said, the idea is to test to get the errors as soon as possible. I don't want to have to deal with permissions when I need the resource. I want to do this as soon as possible. Also, some content, dynamic content, is only known after the creation. Like this example, as we can see here, the name of the bucket is being dynamically created, and I don't know the name until the creation. Let's say if I have a naming convention that I need to follow for bucket, I'm not sure if my code is working. So that's why we need to test. And to help in testing, HashiCorp has developed an experimental feature called Terraform Test, which is a Terraform module that we can use to create tests using the Terraform language itself. It's available since the 0.15 version. It's a separate command. So we have like Terraform plan, we have Terraform apply, we have Terraform test, a different command. It's a different structure. And this module, it really uses the apply and destroy testing method, meaning that it creates, it applies whatever you want, you define in your Terraform code, and at the end it destroys. So we don't need to worry about leaving any garbage or anything unattended in your environment. And that's what we are going to show in the demo. I'm going to use a GCP bucket as an example. I will create a bucket, and then I will try to create this bucket in different locations and use different tests to see if my code is working as I expect. So these are my requirements. Create a bucket and create bucket in more than one location. Okay, let's move on to our code. Okay, here I have my GitHub repository with my code. First thing here you can see, I created a Terraform code that used the Google Storage bucket resource to create bucket, nothing too fancy, name, location, storage class, lifecycle rules, basic stuff for GCP bucket, okay? In order to use the Terraform test, there are a sequence or some steps that we need to take, okay? First thing, the outputs. the Terraform test, you use the outputs to compare whatever you want. So in my case, I am outputting the bucket name because I want to use the name of the bucket to prove that I can create the bucket in my environment. So that's why I am outputting the name at this moment. Also in my variables, you see I am using some defaults here because I will use these defaults to compare what I want. So in this case, I am creating a name default, which is Natalie Test EU627. So this is the name I'm going to use to compare. Okay. Inside of the module, I need to create 2 subfolders to store the tests. Okay, so I will create this, as you see here in the left hand side, tests, and inside of the tests, the defaults. So if I go here, so test default. This is the mandatory structure. So the tests should always live in a defaults folder inside of the module. Okay. And I will have this defaults.tf. This defaults.tf is the Terraform code that I'm going to use to test, to run the tests. So we have these required providers, which is the Terraform built-in test. This is the provider that we use specifically for testing purposes, not for anything else. It's only for testing purposes. I have a main module here that reference the in this case, you reference the cloud storage module that I create and I show early on, this main TF here, which is 2 folders back. That's why we can see the source is always ... because I am going to run the test and the test is going to use the module. This resource, the test assertions, is the resource that I will be using to really write the tests, to write what do I want to test. Okay. In this case, what I want to test is I want to see if my bucket name is, this is what I want. I want this value. I want Natalie test EU627 as I show in the variables. Here, Natalie test EU627. I want this bucket to be created. And I will get this information from the outputs, from module main bucket name, which is this output, bucket name. Okay. So let's just go back to here because I need to run the Terraform test command from the module folder, okay, from the main module folder. And I will just run Terraform test. So now what Terraform is doing is it's creating a plan behind the scenes, applying this plan, and it will check if my bucket is Natalie test EU627. So if I move to my GCP console and I refresh, okay, I can see here I have a bucket with this name, created today as a multi-region in the EU location, default storage, as any other bucket that I want. So the Terraform test run the plan, run the apply, it's applying whatever I want, and as soon as it's finished, it is going to destroy. As you see, there is nothing, there is no more bucket here. And if we go back to our code, you should see that, okay, success. All of the test assertions pass because the Terraform test was able to apply the changes, it compare the output, and it's working as expected. Okay, that's great. So now what I want to do is to test. I created in the EU location. Now I want to test if I can create in a different location. Okay. I will change the name here for Asia, for example. And in my defaults, I will create a second test. So now I want not only to test the name, because I still want to test the name, because I want to run multiple tests. But I see bucket location as well. So default bucket location is Asia, right? So you grab this from the outputs, and I want this to be Asia. I need to add another output because I don't have an output as bucket location. Right here. I know that this is the location that I want. Okay. So now, when I run the Terraform test, it's going to run the Terraform plan, run the Terraform apply. And then it will compare if the bucket name is Natalie Test Asia 627 and if the bucket location is Asia or not. So let's run the Terraform test again. It's creating the plan, it is applying, it's doing whatever it needs to do. So let's move back to the Google console. Let's see what's happening. Okay, it creates Natalie Test Asia 627. It created with the name that I wanted. So this is good. But you see, the location is EU. Is EU because I didn't change in the variables. I just changed the name. So what's going to happen is the Terraform test, the first test for the name is going to succeed, but the second test is going to fail. Okay, if we come back here, yeah. And as we can see here, it failed because the location is EU and not Asia, because we didn't change the location in the variables. So let's go back to the variables. The name is fine. Okay. Asia. And I will run again Terraform test just to make sure that I have the permission to create a bucket in Asia. Okay, the name is correct. And now the region is correct as well. So what I expect now is that when the Terraform tests finish, it will be able to succeed with both tests for the name as well as for the location. So these are the two tests that it is going to I see. Success. All of the tests are session tests. So I was able to create the bucket in Asia, create the bucket in EU, and both tests work fine. And here you could see as well that we are able to run only one test or run multiple tests at once. You don't need to create one test, one file per test as you want. You can have everything in one go, and you can add as many tests as you want, as long as you have like the outputs, the variables defined, and everything else. Okay, so that is pretty much for the demo. What I'd like to show you guys. And to talk about some of the current limitations, as I mentioned, it is still an experimental feature. So there are a few limitations on how it works. I'm highlighting here two that I think that are important. So the current tests are written in, can only exercise the create and destroy behaviors. You cannot like update or manage stuff. It only creates and destroy. It's pretty much that. And the capturing for context about failures is still limited. So the errors are not sometimes very explicit. So you need to, if I come back here, for example, you might need to run so with this command, for example, the JUnit XML, it will allow you to see a logs file in XML format. So you can see what's happening behind the scenes sometimes, because the errors are not very clear yet. And so yes, please refer to the HashiCorp documentation for a complete list. Also, you can go to the GitHub of HashiCorp and provide feedback on this tool. This is definitely very much appreciated for everything. Okay, that's all that I want to show you guys. This is a good starting point to how can you use Terraform to test and to see how this goes. Okay, so thank you for your time.
This is a good starting point indeed. And from here, we're going to go to another starting point, building Vagrant plugins with Sophia from the Vagrant team.
Hey everyone, thanks for tuning into my talk. Today we're going to talk about building Vagrant plugins with Go. It's going to be a pretty quick one, so let's get into it. I'm Sophia. I'm a software engineer on the Vagrant team. So last year we were here and we talked a little bit about Vagrant and Go and Ruby and how we were planning on transitioning from Vagrant being a Ruby project to Go and how we were going to make that happen. Today we're going to actually be building a Vagrant Go plugin. So let's take a little bit of a refresher on how that whole architecture looks. Basically what we have like a Vagrant core written in Go, and then we use Go plugin in order to interact with all of our plugins. So we have like Vagrant Go plugins that implement our like SDK. And then on the Ruby side, we have like this Vagrant shim, which acts as like a translation layer between like being able to interact with the gRPC API, which Go plugin needs, and the actual like Ruby like API. We can take a look at the RPC definitions for our like services. They all kind of have the similar form. They have like the functionality that you actually want. So for our guest service, we need to be able to detect a guest plugin, and then they have their corresponding spec, and that's allows a little bit of flexibility on the plugin implementation side. So we're gonna see the result of that when we build our plugin. And then on the SDK side, we have this component interface. They all have similar forms as well. It's like the functionality that you want, and then Func. That's the name, and then they all take no arguments and return an interface, and it's going to be the interface is going to be the function that you actually want to run that like does the the heavy lifting of that functionality. So let's go ahead and build something. So today I've chosen to build a Parrot OS guest plugin. This is a Debian-based OS. And now that you know as much about Parrot OS as I do, we can all build this together. So the first thing we're going to do is clone our repo. So we have like a little skeleton repo. We're going to then implement our like detect and parent functions. So implement our guest interface. And we're going to build a plugin. We're going to install it into a Vagrant project, and we're going to run it. So here we go. I've already copied down the repo. Here it is. So that's step 1 for free. On to step 2. We're going to do a go mod init to like start up our project. So go mod init, and then soapy1, and then Vagrant guest Parrot OS. That is a descriptive name for this plugin. We're going to ignore what the terminal says because it lies. And step 3 is actually to go update some stuff around. We have like a placeholder, my special guest. We can do better on naming here. We'll call this guest Parrot OS. And all that, and then we'll update the comment. And then moving on to main, this my special guest doesn't exist anymore. It's actually Parrot OS. And the name of this plugin we'll call Parrot OS as well. And then we got to update this import here. It's Parrot OS. Cool. So that all looks good. Next step is to do a mod tidy. And then we can build it to make sure it all works, or it all builds. Cool. So we're in a good state. That means we can go ahead and fill in the implementation. So let's go ahead and do that. So here is our guest plugin. We see it has the guest detect func. So that's the bit that we need to implement to satisfy our component interface. I'm just going to return a function and detect. So in order to detect if we're running some guest, that means we need to run a command on the guest machine to see if we're running what we think we're running. So the first thing we're going to do is pull out a machine from this target. So target is like a more generic version of the machine that you know and love if you've been inside of Vagrant's internals. The target is something we introduced in this version of Vagrant, but we're going to use the machine here. We can output a little bit error if we have trouble getting the machine. We shouldn't. It should be good. Okay, so let's make sure we have the machine that we all know and love. Cool. And then with this machine, we can pull out a communicator because that's the thing that we need to run a command on the guest. So that's just running the communicate function, machine.communicate. We can do a little bit of error checking here. Cool. Oh no. Okay, so now we need to decide what command we want to run. This is like the money of like the guest plugins. So let's define a command, and we'll say cat etc os releases, and we want to look for ID equals Parrot. Cool. So now we're going to use the communicator to run the test function, and that's going to connect to the guest machine. So we give it the machine, and it's going to run our command on it. And then it's going to output a Boolean or an error. The Boolean will be like if it succeeded or if it failed. So one nice thing to do at this point for our own sanity for this demo is to get a terminal, like a terminal UI, so we can like output a message to the user. So here it is. We can run a UI.output, and we can say we found it or we didn't find it. Cool. And we can return if it's found or if it's not found. And yeah, that detect function looks okay to me. So moving on, we have parent func, and that also is part of the API that we need to, or part of the interface that we need to implement. So I mentioned earlier that Parrot OS is based on Debian, and I know for a fact there is a built-in Ruby plugin for Debian, and it's called Debian. So we'll name that here, and we'll be able to use all of the capabilities that are defined by that plugin. So we could go ahead and define a few more capabilities for Parrot OS, but we really don't need to in order for a Vagrant up to work. So we're going to skip that for now. Also note that this Debian plugin is in Ruby, so you're able to use Ruby plugins from within Go plugins and vice versa. So let's go ahead and build this thing, and that looks good. So we're going to install it into our project. So I already have this Vagrant project set up. It's Parrot OS. It's using the box that I called Parrot OS, and I've already imported, I built it locally and imported it into Vagrant using the Vagrant box command you might be familiar with. So now we need to install the plugin. So plugin installs for Vagrant plugins, or for Vagrant Go plugins, goes into Vagrant plugins. So we make that directory, and then we can just plop our binary into that folder. So now Vagrant should know that that plugin exists. We can run a Vagrant up. So at this point, Vagrant is like starting up like Ruby and loading up all the plugins. So it'll be looking in our .vagrant/plugins directory, which is where we plopped in our plugin, and then it'll also be looking in like the basis directory for any plugins that are there. So that's where you can install like Vagrant wide plugins. So right now this plugin is only usable by like this Vagrant project. So we're going ahead and importing that base box. You notice that we're bringing this machine up with the virtual box provider. So that's actually a Ruby plugin. And then we can take a look at the processes that are running. So we have our Vagrant up, which is a command we ran. And then you can see that we have this Ruby process running. So the Ruby process is running like this Vagrant serve. Vagrant serve is a command we added that starts up Vagrant as a gRPC server. So that's like a long running process that is going to serve as like the shim. So we can use like Ruby plugins in Go and vice versa. So you can see here that vbox manage is being run by that process. And that tracks because we saw in our Vagrant UI that we were running with a VirtualBox provider. And then we see these other couple of plugins, other plugin, my plugin, HTTP downloader, and those are a couple of built-in plugins that I have set up in my environment. And then we have our Vagrant guest Parrot OS, and that's the plugin that we built and installed. So here, Vagrant is booting our guest, or VirtualBox is booting our guest, and Vagrant is waiting for SSH to become available. So classic Vagrant experience that you're familiar with. Good time to stretch your legs while the machine is booting. And so once the machine is booted and SSH connection is established, then that'll be when the guest detection is happening. So we can expect our Parrot OS plugin to be running at some point, and there it is. That's our little message that we output. Detecting Parrot equals true. So that means our plugin ran. It means that our communicate function worked. So that's using a Ruby plugin from inside our Go plugin. And then we see that we're mounting our shared folders now. And so that's going to be running capabilities from the Debian guest plugin, which we said that our Parrot OS plugin that we just defined is like the child of. So that was a successful Vagrant up. So that was a successful build of a plugin. So if you would like to contribute to the Parrot OS guest plugin, it's up under my GitHub user at soapy1/vagrant-guest Parrot OS. You can build it yourself if you want and run Vagrant with it. Or you can go ahead and build your own Vagrant guest plugin. We have a template repository set up. It's at soapy1/vagrant guest plugin skeleton. That's just a template repo. So GitHub Magic will make that easy for you to get going. Thanks for tuning in. And I hope you have wonderful rest of your talks. Thanks. Bye.
So if you've never heard of Parrot OS before, today you've definitely heard of it. It is a fun choice to start with, slightly limited, but that also makes it much harder to break things. And, you know, with the right Vagrant plugin, you can also actually use it the right way. Meanwhile, we're up for our next talk. Derek is joining us again to talk about Nomad Open API.
Hello, my name is Derek Strickland. I am an engineer on the Nomad team here at HashiCorp. You can find me on GitHub or on Twitter at Derek Strickland. And today we are going to talk about the Nomad Open API project. If you're not familiar with the Open API specification, you can find it on the internet at spec.openapis.org. They're currently on version 3.1. The specification is essentially an open standard for how to define a schema for an HTTP API. And why would you want a schema? Well, if you've got a schema for your API, then machine tooling can read that schema and do interesting things. And in today's demonstration, we're going to show how the machine tooling built by the Open API Generator project can be used to generate clients in a number of languages. If you go to the openapigenerator.tech website, which is the main website for that project, you'll be able to see a list of generators. And this is an incomplete list. If you go to their GitHub repo, you'll see that there are a lot more. Today, we are going to focus on generating a new client for the Nomad API with the C# Net Core generator. So let's go take a look. So we kind of talked about what the specification is. Let's take a quick tour of our repo. You can find our repo on GitHub at github.com/HashiCorp/nomad-open-API. In that repo, there are a few things of interest. The most important thing is under this v1 folder, you'll find an OpenAPI YAML file, openapi.yaml file, and that is the actual specification document. You can see I've got most of the elements of the document collapsed so that you can kind of see a high-level outline. But inside each one of these sections, if you were to expand them, you'd see a bunch of YAML like this that sort of describes the surface area of the API. In this case, there's a parameters dictionary entry that defines all the possible parameters and whether they exist in a query string or a path or a header, and what their name is, whether they're required, and what their schema type, yada yada, and all that that same sort of structure flows through all of these different areas of the specification document. So we've generated that document for you. As you can imagine, if you look at this, this document is almost just a hair shy of 8,300 lines of YAML, which is a lot of YAML to try to maintain by hand. We don't do that. We built some custom tooling to look at the existing API. I should mention that the Open API specification is sort of optimized for a design-first approach where you build the spec document using some sort of an editor studio like Stoplight. But in this case, we had an existing API, and there's not a lot of great tooling for generating a specification file from existing code. So we built our own, and that is over here in the generator package. I'm not going to cover that much today. You shouldn't have to interact with that too often, if ever. But if you're interested in the metaprogramming that went into generating the spec from existing source code, feel free to take a look at that and let us know if it helps you in your projects. So using that generator package, we were able to create the specification document. So that's pretty cool. Now we have a spec doc. What can we do with it? Well, we can use it to generate client code in different target languages. And so how do we do that? Well, we have a make file over here. And in this make file, we've defined some different commands. You're welcome to take a look at the different make targets. The one we're going to focus on today is make v1, which is going to make v1 clients for a number of languages using the specification document that was generated by our generator package. And what it does is just a series of Docker run commands, okay? And these commands are pretty, sort of parameterized. And then you'll notice that we just kind of feed it a different directory as the last argument for each target language. And those directories are all over here in the clients folder, which is another folder of interest for you. And when you create a new client, this is where it should get output if you configure everything correctly. If you decide to add a new target language and your code does not end up over here in the exact same directory structure, the PR is probably not going to get approved. But if you just need it to generate it for yourself and you're not planning to put it in a PR, then that's fine too. All of these directories have the same structure of, generator name, v1, and then very important underneath each one of those directories is a config.yaml file that's worth mentioning. The configuration file has a set of common parameters and then a set of parameters or config settings rather, that can change based on which generator you're using. So if we go back over here to the generator list, you can click on any, whichever target language you want, or if your language is not in this list and you're doing it from the repo, sort of a similar process, they'll all have a markdown file in their folder inside GitHub. And that markdown file is going to tell you, hey, these are the config options that you can set for your particular generator target. And in the case of .NET, some of them have, a handful at most. The .NET core, or C# .NET Core package or generator has a ton. I've only set a few. And in my case, I just said, hey, here's our license ID, Mozilla Public License version 2.0. Don't generate timestamps inside the source code because that can create, churn on PRs for things that didn't change. And I want you to call the package the nomad.client. Back to our quick agenda. All right, so we kind of completed the tour of the repo, but how do we actually do this? How do we add a new language? So if we go back to our handy dandy make file, like I said, I've gone ahead and created the correct directory structure. I've created a config file. Now, in a typical use case where I want to add a target language that is going to get generated every single time the workflow runs, either whether it be CI or a manual build, I would just basically copy one of these, paste it to the end of the list, and then change the package name in that path, and it should all just run. But if I were to run, we want to actually see the output of running this command today. So in order to save us a little time, I just built a one-off make target for just the C# net core. As you can see, I've already run it once over here, so apologies. I'm the big reveal. Just imagine that didn't happen. So I've created this one-off make target, and we are going to run it from the command line. So we just say make C# net core, and it's going to run for a second. And this one's particularly fast compared to a lot of languages. Some of them take quite a while, and boom, it's done. And it just generated all this client code for us. So what's in that client code? Well, a few things. We get a solution file, we get a README file, we get check this out, we get generated documents. Now, again, this isn't something that we at HashiCorp built. This is whoever wrote the C# net core generator had to supply the appropriate information in that upstream package to generate all this. But pretty much all the authors do, or they don't get published. You end up with full docs for your API that you can put into source control, which is cool. You start with a high-level README, which looks kind of like this. And if some of this generated output in the docs isn't exactly correct or not what you expect to see, just remember that is actually coming from the upstream Open API generator package from that project. And so to fix the docs, you either have to override them in your config, or you've got to contribute to that upstream generator project to reflect the change in your docs. But it's pretty cool. And here's an example of what your code might look like if you were going to consume one of the generated clients. And I'll point out that it's a little bit boilerplatey. You can see here, you got to create a new configuration every time you want to run a client, and you've got to, add certain things and so on and so forth. You got to define all your API and set these, parameters that happen again and again. In the case of Nomad, like almost every endpoint accepts a set of 8 or so query string parameters, and so you don't want to be defining that over and over again. So the point I'm making here is that the generated code is completely usable if you just want to maybe call 1 or 2 functions against the API. Real quick before we move on, let's take a look at, here's an example of generated documentation for a specific method. So it's really nice. It's really user friendly. However, as I just mentioned, it's also pretty boilerplatey, right? So like every one of our endpoints is going to take this job name, or pardon me, this region, this namespace, index, wait, stale, prefix, token, per page, next, like all those. You don't want to be writing that again and again and again. So if you're gonna expose a significant portion of the API surface. So another thing that we built for y'all is over here in this V1 folder. It's a reference implementation of how you could write a service layer on top of the generated client, and sort of an abstraction over the boilerplate. And in the API package, if you want to take a second to peruse through it, you might gain some inspiration about how you could write some framework type code to reduce the boilerplate in the code that you have to write. Another option you have, if you're really into mustache templates, you could actually write a template and inject it into the generator workflow through the config file, the config.yaml file, and say, hey, here's an extra template I want you to execute, send the object model to that, and you might generate your whole service layer. And then you don't need to be quite as frameworky because it's generated code, and it could be boilerplate, wouldn't really matter as much. But in our case, we wrote a little framework around it because we wanted to experiment with all the different edges. We're at a 0.1.0 release right now. We've stopped for a request for comment phase. We're hoping folks will come and raise issues with the implementation, let us know what works well, what doesn't. So just an example of what we did in our reference implementation, we just kind of wrote helper methods around things like, hey, get me all the allocations for a job. And we wrote some frameworky stuff like, hey, call and, execute a query, which means a get. And you can look at the internals of that for exactly how that's abstracted away. But yeah, and then by putting this service layer on top of the boilerplate code, you can then make simple one-line calls to your client API surface like that, which would be much more preferable if you're using a ton of different endpoints from the generated client. So let's see, from here, let's talk a little bit about next steps. We looked at the output of what happens for each client, the docs that get generated. We are currently looking for help. We are a Go shop, and we need folks that are experts in other languages to kind of come in and help shepherd the community along. We've built a reference implementation in Go. It'd be neat to have other reference implementations in other languages. They could be done in your repo. They could be done in ours. Whatever. We'll work it out. We have some open issues that we're always looking for help on. Some of them are language specific. For instance, we've got some open issues right now in the upstream Python generator. Would love some Python expertise to come in and help us figure out that upstream challenge so that we can fix, we can get a PR submitted there so that we can consume it and fix some of the generated output. We're also we got some endpoints that are streaming in nature. The Open API spec does not handle streaming endpoints the way we would like. There are workarounds, but it isn't the approach we'd want to take. And so we're looking at using another complementary specification based off of Open API called Async API to encapsulate and define and expose our streaming endpoints like the event stream and exec. So we'd love, if you've got async API expertise, we'd love to get your input and help on building that out. We have a community meeting every month. You can contact me at dstrickland@hashicorp.com if you would like an invite to that monthly community meeting. We are always looking for pull requests. We're always looking for feedback. Raise an issue. Even if you don't have a pull request, you don't know how to fix it. If there's an issue that you're having with consuming it, please let us know. And we hope to see you on GitHub. Have a great day. Thanks for joining us.
That was just beautiful. It's a call that bears repeating. If you have an issue, if you have thoughts with any of our tools that we talked about today, leave an issue on GitHub. Ask your question. If it's really a question that doesn't belong on GitHub, we'll likely point you to our discuss forum at discuss.hashicorp.com. But likely, if you're running into a problem, you're not the only person. And it probably means that we need to fix something. Your feedback helps us build better products. And so with that, let's switch back to Terraform, specifically to terraforming Terraform with the TFC API and the Go client that's built around that. Over to you, Chris.
Hello, HashiTalks Build. Thanks so much for popping into this virtual event from the comfort of your own chair. This is a really cool and accessible event to gather practitioners and user groups. And thank you to the developer experience and other teams at HashiCorp that organize it. And thanks so much for having me. In this Terraform related talk, we're going on a short whirlwind tour chatting about the Terraform Cloud API in general, the primary Go client and that wraps that API, and the associated Terraform provider that a lot of users, HashiCorp itself included, actually use to ultimately provision Terraform using Terraform, which is a fun little cycle to think about. My name is Chris Arkand. I'm a principal engineer here at HashiCorp, where I focus on, you guessed it, Terraform and Terraform Cloud. You can find me on the Twitters and at GitHub and most everywhere else on the internet as @ChrisArcand. So if you're watching this talk, you probably already know what a Terraform is. It's the open source de facto tool for multi-cloud infrastructure provisioning. We're going to talk about one layer past that point about the commercial platform built for Terraform by HashiCorp called Terraform Cloud. And Terraform Cloud, or TFC, is a free-to-use self-service SaaS platform that extends the capabilities of the open source Terraform tool and adds collaboration and automation features. Whether you're a small team looking for basic state management or remote execution, or you're a massive enterprise looking for things like audit logging, self-hosted agent runners, et cetera, it's a really neat platform we built out to really enrich your Terraform experience. So the thing that really powers the entire platform at its core is this thing called the V2 API, or the version 2 of the API that we built for it. Let's talk about that. There's 4 big points that I kind of want to go over. One of them is that this whole API that the platform is built on is JSON API compliant. So it follows a specification that kind of gives it this really consistent look and feel. It's very comprehensive. It includes the majority of all the functionality that you see in the user interface of the entire platform. It's very stable. It's backed by our stability policy, promising backwards compatibility. So you can build stuff on top of it without feeling like all that is going to change on a moment's whim, right? It also has a consistent look and feel with the documentation, but more importantly, it's comprehensive documentation that allows you to really find what you need as you're building things on top of it. So kind of going into each one of those things in a little more detail, as I said, it's built on the JSON API specification. The JSON API specification is this adopted open spec that you can look at on the JSON API website, and it specifies the overall feel and design of the API. Most notably, the things that it kind of specifies are HTTP error codes, so what errors you should expect back given some sort of errored state. Error objects, so the data and detail about what error occurred to be in a consistent state. The document structure, so a resource as a remote object in the API, what does the response look like? What could you expect each thing to look like? And the HTTP request and response headers. What are the sorts of headers that you should expect on every single request and response in the API? So here's an example of what one response might look like. Every sort of document response includes a resource identifier that has a body that looks kind of like this. So there's always a data key, there's always a consistent type, and that type is unique across the entirety of the API. So if you see a vars type in one spot, if you see that in another request elsewhere, you know that it's the same sort of resource. You'll always see an attributes key with whatever attributes that specific resource declares. And then you'll usually see a key called relationships, which signifies how one resource in the API is related to the other. So for example, in this case, this is a variable resource, and you can see that it is related. It's included in that particular workspace at that particular identifier there. The next point was that it's really comprehensive. So everything that you see on the screen there, this is literally just like the sidebar of the terraform.io website with all of the different documentation there. There's a lot here, right? There's an API for agent pools, agent tokens, applies, comments, OAuth clients, runs, plans, workspaces, users. I'm not going to go and list the whole thing, but as you can see, it includes basically everything possible in the Terraform Cloud API, or sorry, in the platform is in the API. And that's a really powerful and really cool thing that we will see. Lastly, it's very stable. It has a stability promise that we've put forth, I think it was a couple of years ago now, that basically says, we're not going to change everything out from underneath you. You can feel confident building the sort of deep integrations that you want to build without everything being thrown away. It's very compatible. We're going to make sure that we only add to it and that we don't break anything, subject only to security vulnerabilities. If there's something wrong there where we need to make a change that is backwards compatible, we'll go ahead and do that, but we'll make sure to notify you of it, and that's a very rare occurrence, really. Lastly, it's well documented. So there's, as I said, there on the Terraform.io website at Cloud Docs, there's a really great site that the education team has built out that documents all of the different aspects of this Terraform Cloud API and their behaviors. It's really, really quite awesome. So with this really comprehensive, well-documented API, you might be wondering, who really uses this thing? A lot of things. First off, Terraform Cloud itself. So the reason why that API is so comprehensive is that TFC's entire public user interface, so the user interface that you use to click around and work with Terraform Cloud, it utilizes that public V2 API. So it's not any sort of situation where we have a stack where we just kind of expose things as necessary to the API. We design it. We are forced to design it really as a intentional thing. We're forced to design it as like a consumer of ourselves. So we put a lot of thought into how the API is designed, not only because we want you to be able to build on top of it, but we literally need to be able to build on top of it for Terraform Cloud itself. Another thing that uses it, Terraform. So the Terraform CLI, the tool that you know and love, integrates with Terraform Cloud via this API. When you're doing things like remote operations, starting a Terraform apply in your console that kicks off a build and a run up in Terraform Cloud and streams it back to your terminal and all that business, that is all done via this Terraform Cloud API. Other HashiCorp tool integrations, other stuff definitely uses this Terraform Cloud API. These are the ones that I've personally worked on. I'm sure there's more, but I know that there's integrations with Vault, with Console, with Waypoint. I'm sure there's some on the others, but as I said, this is my own personal experience anyway. AWS. So AWS Labs, and more importantly, just command line interfaces in general. There's a whole bunch of command line interfaces that have been built out for Terraform Cloud or Terraform Enterprise. And they are all built, again, on top of this API. So this one's a really popular one, again, from AWS Labs that it wraps around the API. There's also other ones. So I know CBS Interactive has another one called TFC-CLI. There's a community one called Terraform Control or TFCTL. And there's also an unofficial HashiCorp one called TFX as well. So there's a lot of these different wrappers around, using Terraform Cloud and managing it in your command line as well. And you. So more generally, without all of these other projects, our users and our customers here on Terraform Cloud really do utilize and exercise that API via custom scripting and all the different things that you can build that don't necessarily, use a proper command line interface or anything like that. All that CI automation, stuff like that. The API is just so comprehensive and you can do so many different things with it that we see people utilizing that API interface quite a bit. So, how do you consume this sort of API? Like, if it's used by so many different things, surely there are some solid API clients that really take care of the minutia of authentication and pagination and all those different things. Well, there definitely is. So the official one that we maintain and HashiCorp maintains is called Go TFE. It is a Go client, and you can find it in the Go packages website and all over on GitHub. It's HashiCorp/Go TFE. It is the official Go client for TFC. Very, very comprehensive, wraps everything that you would expect, in the API And it is really the integration point that a lot of the consumers of the API that I just talked about, Terraform itself, that AWS Labs tool, the provider that we'll talk about in a minute, all of those different things, they directly use this Go package, this Go TFE client. By the way, it's called Go TFE. So the TFE designation is kind of a historical term. So like the service used to be called Terraform Enterprise. Now it's called Terraform Cloud, and the on-prem version is called Terraform Enterprise. Whatever. The most important thing to remember is just that when we say TFE here, it's really Terraform Cloud and the on-premises version of Terraform Cloud, which is called Terraform Enterprise. And this, just quick, is kind of what this looks like. It's exactly what you would kind of expect from a Go client. You're able to create a workspace, update that workspace, et cetera, et cetera. So beyond Go TFE, there's several other community-supported clients. This is a whole bunch. I'm not going to go over each and every one, but the main point is that a lot of the ones here, the popular ones on the screen that I have here, they're not just Go. Like there's a client for Ruby, there's a client for Python, for .NET, for Bash scripting and all that sort of stuff. Yeah, there's just a lot of different languages. You don't need to use Go necessarily to wrap the Terraform Cloud API within the client. So we have this really comprehensive API, as I said. As a Terraform user, you know that you every day plan and apply changes via these providers to all these different things, right? Well, you can provision changes to AWS, to GCP, to Azure, whatever, right? If there's this really comprehensive API where you can manipulate things and build things, etc., you might instantly be thinking like, well, what if it's just an API, does that mean we can Terraform Cloud? Can we actually create and plan and apply resources to Terraform Cloud using Terraform? What's stopping you? Well, the answer is absolutely nothing. You can totally do that, and people do that quite a bit. And taking it another step further, you can also use Terraform to use Terraform Cloud to plan and apply changes in Terraform to Terraform Cloud, which is the fun little endless cycle that we'll talk about here. How are we able to do that? We're able to do that via this thing called the TFE provider, which allows you to, again, provision Terraform Cloud or Terraform Enterprise with Terraform itself. Really popular provider. We have a lot of users that utilize this a lot. Again, very comprehensive, covers a whole chunk of the API and allows you to provision all of that stuff in a workflow that you're used to, which is Terraform. This is what it looks like. Again, the API is very straightforward. You can see how to create all of the different stuff in the Terraform platform. Yeah, it works out really, really well. So it's kind of an example for like how one would really utilize this thing. I'll use my own use case as an example. So a pattern that we often see is basically using a sort of bootstrap or meta workspace in Terraform Cloud to then provision the rest of that stuff in an organization. So this is a public repository. You can take a look at it later, where I basically have a set of workspaces coming from an input variable where I can very, very quickly spin up new Terraform Cloud workspaces to use those very, very quickly with very, very minimal configuration. So those values are coming from these variable declarations. This is kind of a random little aside, but I'm so excited about this. This isn't really related to the provider, but I wanted to show it anyway. The way that I do that is using these sort of optional declarations. These optional declarations are a new feature coming to Terraform soon. So they're called optional attributes for object type input variable values. This is an experimental feature that was introduced in Terraform 0.14, but now it is becoming stable in the upcoming Terraform 1.3.0 release. So I'm very, very excited. I've actually been using this for a very long time. It allows you to be able to do things like this, where again, I need to toy around with Terraform Cloud workspaces and all that sort of stuff really quickly all the time. What I actually have is literally just a variables file where I can add one line to provision a new workspace with all of the usual defaults that I really like in a Terraform Cloud workspace and override them where necessary. So this is my variables file. It's literally just an object that declares workspaces, and I just put a name in, and it'll give me a workspace. It'll plan and apply that workspace. And again, I can choose to override. I don't have to have a full Terraform block stanza to set everything. All of my required arguments and all that sort of stuff can be implicitly, implied here in the variables file. So that's pretty cool. Main point though, again, we have this meta workspace here. What that allows is the ability to bootstrap everything else. So you'll see this pattern a whole ton. We have a lot of users that do this. This is really powerful stuff. This means that for the same reason that you don't want to be clicking through your cloud provider user interface, configuring all that stuff, you can apply that same sort of principle to Terraform Cloud itself and terraform your Terraform Cloud. So in summary, again, TFC has this really comprehensive, really thought out developer API. It's got a whole bunch of different clients, including the Go official one and several third-party ones in other languages. There's a Terraform provider for the Terraform Cloud platform itself. There's an integration in Terraform CLI with TFC, and there's all sorts of several third-party command line tools to go with that as well. It's extremely extensible is really what this talk is all about. And we here at HashiCorp building Terraform Cloud utilize that a lot ourselves as well as our customers. Terraform Cloud is really built with Terraform Cloud. So a lot of our development practices and how we're releasing features on the platform and provisioning things that underpin it and whatnot are actually using Terraform Cloud itself or separately Terraform Enterprise and whatnot to do those things. And it's a unique and awesome thing that I don't forget to appreciate every day, that we get to work on this tool where we get to use it to build the tool. And that sort of dog fooding, that's an opportunity that not everyone gets. And it's a cool experience to really see how you can make the tool better because you are a user of your own tool. And that's about it. That's all I got. Again, my name is Chris Arcand. I'm a principal engineer working on Terraform at HashiCorp. You can find me basically everywhere as @ChrisArcand. And don't be afraid to reach out and say hi. I love chatting with users and gathering feedback for how to make Terraform better for you. Thanks.
Terraforming your Terraform to terraform your Terraform Cloud is really the only way to terraform your Terraform infrastructure. I mean, I couldn't think of any other way. With that, we're actually nearly at the end. We've got one more talk. If you've been at HashiTalks 2021 last year, you got to see Chloe's talk, Should We Build It? An ethical framework on answering just that question. Software is built by people. People have ideas. People have ideals. And sometimes those can be misguided. If you haven't watched it, definitely recommend checking that out. But for now, we'll answer the question, or we'll not so much answer the question, but we'll think a little bit about the future, because tomorrow can be a wonderful age. Chloe, over to you.
In a moment, I'm going to open my talk by sharing a poem with you. First, a little housekeeping. Hi, I'm Chloe, and for the next half hour, I'm going to talk about ethics and technology, a fraught topic at the best of times. Given that too many of us are using a fine dog meme in status updates these days, please be kind to yourself and take a break from this talk if you need to. Ultimately, this is a talk about hope and the future, but to speak to that, we have to understand and squarely face our current reality, no matter how uncomfortable or harmful. One last thing before we begin. My engineering orientation is operations and problem solving. I started as an SRE, and I believe very strongly in the value of blameless retrospectives and reflective learning. I ask that as we engage on this topic, starting with this talk and hopefully branching out into our communities, we hold that ethos as our foundational principle. While there's a lot of pretty awful stuff we're going to have to face if we're going to fix it, the way out is to solve problems, not find people to blame them on. With that out of the way, I promise to start with a poem. When I was a kid, I used to ride the bus in San Francisco. On Muni buses and streetcars, there used to be poetry in some of the ad slots up by the hang strap bars. This poetry was paid for by the ads and probably the city and state, as well as the National Endowment for the Arts in one way or another. So I'm pretty sure it's gone now, unless some startup thought funding it would be good PR. My favorite of these poems was a tiny poem, a single verse, 23 syllables, The Mysteries by Lori Duggan. I ask you to take a moment to pause with me. Collect yourself to be present in this talk as I share it now. Everything happens at once. We miss most of it. The kettle boils over and puts out the fire. The kid that fell in love with that poem was living at a pretty strange time. It was the 1990s and post-Cold War optimism warred with slacker burnout. Anything was possible with a Coke and a smile, and really big pants were kind of a thing. The internet was a free-for-all, most easily accessed through educational institutions or libraries. For me, as a weird, queer as in gay nerd girl, it felt like freedom. Okay, quick aside, here's a weird trivia fact about me. I was homeschooled for most of middle school. To support my education, my mom managed to save enough money to buy a used computer, and we got a home connection to a dial-up ISP. Through Usenet, the World Wide Web, and IRC, with mom always nearby if I had questions or needed help, I found a whole new world. Even back then, though, there were some places it wasn't safe to be too much of a girl on the internet, and some places it wasn't safe to be a girl at all. Much of the common vernacular was racist, ableist, sexist, or homophobic. Walled gardens, such as America Online and CompuServe, existed to put a mostly family-friendly veneer on what was presented at the time as a lawless Wild West, even by its champions. But the digital age was coming and the 21st century was dawning and things were going to get better. If we partied like it was 1999 and survived the Y2K bugs, we'd be in a new golden age. Thanks to Moore's Law and decisions made for social, political, and financial reasons, the price of tech manufacturing kept falling. Technocratic optimists and professional futurists predicted this would be the turning point where humanity would make its next great leap. In front of us, the opportunity to remake the world. And we, humans collectively, failed. As the cost of creating technological components decreased, we distributed them unevenly. Mines and factories were set up in resource-rich places, finished products shipped away because these countries didn't have the infrastructure or framework to use them anyway. The final homes of these components were determined by an astonishingly small group of people concentrated in a handful of locations around the world. The haves got more, the have-nots lost yet again. And the first iteration of our digital universe, built on the shaky foundations of exploitative manufacturing and a completely unintentional culture created mostly by bored math and science students, was thus directed from a handful of corporate campuses, almost all located in the San Francisco Bay Area. Still, on top of this cheap and abundant hardware, we had another chance to build. And once again, before us as a species dangled the promise of a better tomorrow. Software development could be the great equalizer, could be learned by anyone, could remove human bias, could improve quality of life, could be the great and powerful Oz. That great and powerful Oz thing should have been a giveaway. He's a character in a book and later movie about a girl from Kansas who gets lost in a fantasy world. She believes the great and powerful Oz is a wizard who can save her. Only it turns out Oz is just a powerless charlatan hiding behind a curtain, pulling levers to create a giant hologram of a face and speaking through a tube to amplify and distort his voice. At best, he's a pitiable failure. At worst, a malicious predator, using the girl's desire to go home to strong-arm her into committing a murder. Instead of the utopian world we were sold, software engineering took on a mythical quality incentivized by an irresponsibly sized influx of money that functioned best when replicating existing relationships and social structures. We made the creation and maintenance of software almost mythological, preferring origin stories that began at Stanford, MIT, Berkeley, or getting arrested for hacking into a phone company. And then we built a world of extractive microtransactions and loot boxes and ad systems designed to figure out your heart's desire and put it in front of you, and always on digital assistants who send your recordings back to a company that only exists to sell you things to feed the Hydra's other heads. We bought an idea, hook, line, and sinker, about meritocracy and computers being impartial. The joke's on us. They'll impartially execute whatever bias you've programmed them with and not even blink an eye. They don't, after all, have eyes. A computer will never tell you you've just accidentally excluded people of color before invisibly redlining your housing ads because the search criteria were cultural and not racial. A computer will never tell you that automatically rejecting resumes with a 5 to 10 year work history gap is probably sexist. And as your friendly neighborhood nihilist will cheerfully tell you, merit is a lie because there's no such thing as objective meaning, though that's a talk for another day. But everyone knows that investors need to make their money back, and a good story is worth its weight in marketing gold. And so, as an industry, we wrote a collective creation fable for ourselves that algorithmic decision-making and machine learning would be our literal deus ex machina. The computer would be benevolent and wise. The computer would transcend our petty human emotions. The computer would bring order and justice to the galaxy. And we collectively agreed to ignore the man behind the curtain, writing the code to make the computer go. In the interest of time, I'm going to skip us forward to the present. While I could spend a whole talk just exploring how we got here, this is still a rescue mission, not an archaeological dig. Today, we're more than 2 years into a global pandemic that changed our world and our lives. We're confronting climate emergencies and failing infrastructure and the very lethal Venn diagram where those things overlap. In the United States, we're experiencing an epidemic of gun violence, but the world over, we're not just seeing, but experiencing greater divisiveness and polarization, leading to violence against already marginalized groups. We use cute phrases like post-truth to minimize the distress we feel over informational context collapse and institutional distrust. We spend more of our lives than ever on the internet, connected to our devices and connecting to others through social media. Where bots were once charmingly clunky and obvious, they are now the well-honed tools of disinformation artists and other malicious actors. And we as individuals have to somehow discern them from our friends and family. We are surveilled constantly, not just by products we use for free, but by ones we pay for. And we often have no idea what data they're collecting or how it's being used. I actually have to stop here for a second and talk about this because it's absurd. Actually absurd in a Samuel Beckett waiting for Godot sense. Have you heard the one about Tim Hortons? On June 1st, the Office of the Privacy Commissioner of Canada released a report of their findings in a 2-year Personal Information Protection and Electronic Documents Act investigation of the fast food and coffee retailer Tim Hortons. The investigation was triggered by an article in the Financial Post by James McLeod, who installed the Tim Hortons app and discovered just how much data they were collecting about his location. James wrote, "I didn't realize how much until I saw my coordinates in a trove of data that RBI sent to me after I made a request under Canada's Personal Information Protection and Electronic Documents Act last fall. According to the data, Tim Hortons had recorded my longitude and latitude coordinates more than 2,700 times in less than 5 months, and not just when I was using the app. For perspective, napkin math makes that approximately 18 times a day that the Tim Hortons app collected and reported back on Mr. McLeod's location, whether or not the app was open. If that wasn't creepy enough, Mr. McLeod goes on to write, I had no idea how extensive the tracking data was until I saw it. There were readings taken at all hours of the day and night, and RBI kept tabs on me every time the app thought I was visiting one of its competitors. I've added the emphasis. When asked about this, the representative of Tim Hortons suggested that this data collection was all outlined in the agreement to let the app access the GPS, that allowing the app to access GPS was completely optional, and that if Mr. McLeod didn't wish to be tracked, then it was his responsibility to turn off the GPS access to the app. As a systems nerd, I find the report pretty interesting and I encourage you to go read it. But to spoil the ending for you, the Privacy Commissioner found that Tim Hortons did collect the data and failed to collect even an attempt at appropriate consent. For their part, Tim Hortons has agreed to delete the data and never collect it inappropriately again. honest. And this brings us to the hard and ugly truth. Much of what has come before is broken and destructive to individuals, to societies, to our planet. As technologists, we're now trapped between accepting that and remediating it, or continuing to push it behind the couch or under the rug, because each of us is just one person, and the way forward is hard, and we can't do it alone. Everything is happening at once, as Laurie Duggan said, from environmental destruction through crypto mining that's always 6 months away from moving to a more energy efficient blockchain, to systematizing bigotry and abuse through the use of predictive autocomplete results in search that dehumanize members of religious or ethnic minorities, to blind social and systemic pressure to extract as many dollars through microtransactions, subscriptions, and add-ons as possible. There is too much to see all of it. We're left shocked by each kettle-doused fire instead. I'm drafting this in the wake of a trial about domestic abuse that was served up on social media in bite-sized clips like it was the best sketches on SNL to watch on your train to work on Monday morning, as if we should cheer victims and boo their abusers like it's a sport. And in the year of bad date furniture store guy, whose name I'm not using because he's a human being too. I'm writing in the shadow of a racist shooting featuring a manifesto copy-pasted from an internet message board known for being a source of radicalization. So much like the 1990s, it's a strange time to have a relationship with technology. Back then, my messengers of choice were AIM and ICQ on a desktop computer the size of a microwave oven. On February 24th, 2022, I downloaded Telegram to an iPhone that fits in my pocket for the first time, to keep abreast of a war on another continent, and for a while I had a nightly ritual of waiting to see pictures of a sunrise on the other side of the world. The quiet hours of evening spent waiting for inevitable cosmic phenomena became, unsurprisingly, contemplative. I thought about evenings I spent on IRC as a kid, making friends around the world. I thought about my babcha, who fled Krakow fairly young and never returned. I thought, I kid you not, about how everything is a matter of perspective, and the world was so large we'd never be able to know all of it, and so small I could put it in my pocket. I felt a small but persistent defiance. I'm exhausted and angry, and I want more than this. I want you to want more than this too. So with my remaining time in the tradition of the 1990s and its manifesto writing zine culture, I present a declaration of how we should do it instead. A prescription for what ails us, a beat you can build a remix around. And it starts with this: the internet is a real world. Everything we do in tech, every line of code, every instance scaled, every app and algorithm has effects on the lives of others. Now, today. And that must matter more than a hypothetical future. As technologists, we are powerful. We've constructed an entire global communications infrastructure over the last 40 years that still seems almost impossible if you really think about the details. I'm speaking today over a broadcast medium that will make it to space, not from a television studio with complicated equipment, but from the comfort of a home office. The world we live in today could not exist without us. We must understand that power, be responsible in its use, and be accountable for its consequences. It will be hard and scary. It means being intentional in everything we build from the moment of conception. It means committing to exploring all the effects of our decisions, not just the ones that are easy to translate into dollars or your local currency of choice. It means understanding that there's no such thing as an externality if your decision was caused by or results in it. It means holding each other to a higher standard. It means holding ourselves to a higher standard too. A standard defined by the fact that the story of technological innovation is the history of human development. Every invention, a manifestation of intent and imagination where nothing existed before. A standard informed by the fact that we can change reality with a thought and enough electrons. We must center that standard in an ethos that protects and promotes human empowerment, dignity, and social equity. There is a better world possible, not built of blockchain records of right-clickable JPEGs or monetizing outrage cycles, but one that creates access to knowledge and the flourishing of a multiplicity of people and cultures. We used to be brave enough to imagine it, a technological future that resulted in matter replicators, instant transportation, solid holograms, plasma swords, light speed travel, and terraforming. A future where technology was a multiplier of our potential, not an accelerator of our worst days. that world is still waiting for us. But it relies on our choices and our curiosity, our bravery and our strength. It requires us, you and me, the builders and architects, to see its potential and call it forth. And to get very vulnerable and squishy for a moment, it requires love. Not romantic love, not familial love, but a very real kind of love nonetheless. The love of what could be, of the world we could build. Love might seem like a strange word for a talk at a technical conference. We spend so much time in tech talking about hard things, logic and procedure, validation and repeatability. Love can't be validated or benchmarked. It can't be procedurally recorded. So why invoke it? Why bring it up here at the end of a talk about how to concretely build a better world? Because every dream worth dreaming starts from the heart, starts in love. Each of us listening right now, I can almost promise, has a story about something they built from love. An app to stay in touch with someone long distance, a way to help people in their town fight parking tickets, a blog theme with fiddly bits that bring them joy to look at. Each of these dreams started not with how to make a ton of cash, but how to bring love and joy to the world. Since I told you the story about Tim Hortons, I want to tell you another story too. A story about a developer with a little too much time on his hands at the beginning of COVID and a partner who liked games. On November 1st, 2021, 90 people were playing a little game he wrote for his partner. By mid-January 2022, hundreds of thousands of people were playing. This engineer ultimately sold his little game, A Riff on Hangman, to the New York Times. That little gesture of love was Wordle, built by Josh Wardell. When we reach into the place in us that feels love and hope, when we reach into the place in us that dreams of something bigger and better, we don't just build technology. We build connection and human comfort. We build hope and joy. We build belief that there is a better world than this possible and that the limitations we suffer under now can be surpassed. We build a future worth believing in, where suffering is reduced and potential is empowered. That's the more I want. That's the more I want you to want too. The title of this talk, Tomorrow Can Be a Wonderful Age, was the unofficial slogan of Tomorrowland. I was inspired by Walt Disney, who collaborated with scientists, physicists, and others who would go on to build NASA in creating a place where people young and old could go to be inspired by imagining what could be possible. Ray Bradbury, the science fiction writer who has inspired so many of us, referred to Disneyland as a Schweitzer's centrifuge, a place to spin people metaphorically and inspire them, ignite their curiosity, stuff their heads with ideas, and send them whirling out into the world to build brand new dreams. While the castle may be the center of Disneyland from eye level, I believe Walt Disney saw Tomorrowland as its heart, the place people would be kaleidoscopically spun and filled with brand new dreams. At Tomorrowland's entrance on a plaque is the text of Walt's dedication. A vista into a world of wondrous ideas signifying man's achievements. A step into the future with predictions of constructed things to come. Tomorrow offers new frontiers in science, adventure, and ideals. The atomic age, the challenge of outer space, and the hope for a peaceful, unified world. I'd like to close by thanking you for your time today and to conclude with this. If anything I've said today sticks with you, I hope that this will be the thing. That it takes that kind of love and vision to build the future. That we, as technologists, have the power to build it. And that it begins with being curious, imaginative, and brave. Thank you.
There we go. Technical troubles. How do you even follow up something like this? I was so speechless, even my mic decided that I should not be talking right now. So take a moment after we close out to think about what you just heard. Enjoy Chloe's design, which we'll share in the chat with you. And think about what building things means and what impact you can have, positive and negative, by building the things that you're working on. Awesome and thought-provoking. I think, as Martin says, it is the only way to think about this. With that, we are at the official end of HashiTalks Build 2022. And I thank you all for being here with us today. This event wouldn't have been possible without all of you. It wouldn't have been possible with all of our speakers and, of course, our behind-the-scenes staff. Jasmine, Alexandra, if you want to jump in, please do. But if not, imagine this virtual applause is for you, because we couldn't have put this on without the two of you. To me, it has been an inspiring event. If you like what we do here, obviously hit the like and subscribe button, or just tell us what you would like to see in the future. We try to make these events interesting for all of us, interesting for you, and yes, thought-provoking. We want to hit you right in the feels with some of these talks and make you build a better tomorrow. Let us know on Twitter, #HashiTalks. I think we just saw lower third for that. Thank you. There we go. And if you like content around our products and you're in a conference mood, check out hashiconf.com. We'll be back in October in Los Angeles, October 4th through 6th. We'll also have a virtual component if you can't travel or don't want to travel, and hopefully see you there. With that, thank you all. And to quote Semisonic, you don't have to go home, but you can stay here.